specifications, so we know why we even talked about these functions. So let's take a look. Here's an example in which we're given a function. What type of function is it?
Rational.
Perfect. Is it type 1 or is it type 2? 1. Exactly, because it's same degree of the same degree. Guys, you're the best. Absolutely the best by far. Good. What is the horizontal asymptote then?
6.5.
Of course, the leading coefficient with the leading coefficient. Very good. Look at the graph. Do we see the horizontal
I
asymptote?
wasn't even looking at the graph.
Good. So this is the graph, but I wanted you to look there first. Yes, perfect. So here's the deal here. This function apparently models the pH level of the human mouth X minutes after a person eats food containing sugar. So let's look at the pattern first, and then we'll analyze and see what they want. So obviously it starts here, where it's, I'm assuming, the normal pH of the mouth. We swallow food with sugar. Here's what happens quickly. It comes to a minimum, and it appears to be 6 minutes. Something like, I don't know, 4.7, 4.8, whatever, I'm not sure. And then over the next almost an hour, it takes an hour to basically go back to the normal level. That's how I see or look when I look at this graph. This is what I understand from it. Okay, so now let's answer a couple of questions. Part A. Use the graph to obtain a reasonable estimate of the pH level of the human mouth 42 minutes after a person had food with sugar. So 42, I don't know, it's very hard to read, right? So I'll say a little bit over 60, but I don't know how much. It appears to be a little bit over 60, right? Over 6, I'm sorry, 6.0. 42 minutes. Okay, after eating sugar, when is the pH level the lowest? Yes, so remember when we talked about increasing, decreasing? So we are asked, what is the lowest? And of course, it's decreasing between 0 and 6 rapidly. And between 6 and 66, obviously, I see the function is increasing. So 6 minutes later, it has a minimum. And what is the minimum? So first of all, we were asked when, and you said 6 minutes, perfect. And then what is the minimum? 4.7. According to the graph, what is the normal pH level? We agree? Perfect. What is the equation of the horizontal asymptote? Y? Yes. Yes. Y equals 6.5. Awesome. Describe what that means in terms of the pH level, the mouth pH level. Eventually, you will go back to normal. That's basically all I needed. Use the graph to describe what happens. We already did. Now, I would like to put this function in the graphing calculator. Clear if you have anything else in there. And evaluate. The reason why I would like us to do it with the graphing calculator is because I want to remind you that every time you put a rational function in the graphing calculator, you need parentheses around the top, and you need parentheses around the denominator. Without parentheses, you're going to get something else. So the left parenthesis for the top, 6.5 x squared minus 20.4x plus 234. Close the parenthesis, divide, open a parenthesis at x squared. I think it's plus 36, yes, plus 36. We do not have to graph it. We're not asked to graph it. I just wanted you to see how we have to put it in the graphing calculator and just confirm with the graph. I didn't mean that. I meant this. And confirm with the function what we looked at. We looked at 6 minutes and we looked at 42 minutes. And let's see if our readings were anywhere close. So 6 minutes we said and 42 minutes. So it appeared that it was a little over 6, as we expected. And 6 minutes later, from 6.5, it drops to 4.8. Any questions? Any questions? It's pretty simple. Yes, please, Victoria.
How did you do that on the graphic calculator?
You mean with the table? Yes. To enter, I'll be right there. So first of all, you want second table set, and you do have that. So second table, and just put in what you want. Yeah, so let's put in 6, and enter, and perfect. Let's put in 42, and enter. You see that? Yes, so you have to go to the asymptote for the just for the independence. And now we go back to second and table. Second and table. Second table. Second and quit. Second and table. Perfect. And now plug in 6. Enter. Great. We have an error in the function, so let's go to like equals. You're missing the X here. It's put insert, second and insert. After you get to that, that's it. Second and insert. And put an X.
You know what probably meant when you did some integer.
So insert 4.
That's why when you on your dependent, your dependent needs to be at all. So now,
Yeah. So then,
it's like if I were to say
put it down
7,
and then you'll get it.
yeah, this only the
So we got
independent
it?
goes
Is
on.
that okay? So go to y equals. Put, re-highlight those, go up, press enter. Re-highlight the next one to the right, press enter, and now go to y equals. Put the left parenthesis. 6.5 x squared.
Calculator.
Say it again. So 6.5 x squared minus 20.4 x plus 234, close the parenthesis, and divide by parenthesis x squared plus 36. And don't forget to go to second and table set. We all have that?
You can put the y value as but the x value goes
The 36.
That might be a little
So we
high.
go to second and table set. And we change the independent into task. Scroll down and to the right, press enter. And then second and table. No, not that one.
Leave that one.
Yeah. So we just put in 6.
Work today before I came
And
here,
what
so
do you
I've been here since 10.
Perfect.
Catch up on math homework.
You don't have to. We have the graph. The graph is in the picture.
I said, do not put any in my department,
Okay.
I'm throwing.
Is this okay? Other questions? Okay, so let's look at one more. So here it is. Okay, so here's another. So here we're given a drug is injected into a patient and the concentration of the drug in the bloodstream is monitored and the function is C of T. The drug's concentration C of T in milligrams per liter after T hours is modeled by. What type of function is it? Rational. Which type? 1 or 2? Exactly. And we hope that, because we hope that whatever medication we take, eventually we expect it to go away. So which means that this horizontal asymptote will be, for type 2, the horizontal asymptote is 0, 0, very good. But we see it here also. So if we look at this function, we first of all, we have to be careful with this viewing window, which means 0, 10, 1, 2, 3, 4, 5, 1, and 0, 3, 1, 2, and 3. So now we're asked, use the graph to obtain a reasonable estimate of the drug's concentration after 3 hours. So 1, 2, 3, it's hard, but I would probably say 1.5. We'll put in the function and we'll evaluate. Let's just do that. So now go back and clear that. Because the numerator has only one term, we don't need to put parentheses, so 5x will be okay. You can, and divide by, but definitely parentheses, t squared x squared plus 1, x squared plus 1, and close the parenthesis. And then go back to second and table, and we want to plug in 3 hours. And the answer is 1.5. The next question is asking us to use the functions equation to find the horizontal asymptote. We already did that. What is the horizontal asymptote? Since it's type 2, we don't even have to look at the graph. We know that it's going to be 0. Good. Any questions? Any questions from this section before we look at the very last one, which is 3.6? Last one for our test. So yes, it is a little bit more involving to graph such a function, but the functions, the models, working with a word problem, not that difficult, I would say. Would you consider that? Yes or no? Okay, so the last section, which is 3.6, polynomial and rational inequalities. Okay, so let's look at a few examples, and you'll tell me which one you think is polynomial, which one is rational. So we're going to look at 3 examples. More by request, of course, anytime. So here's the first one. Here's the second one. And here's the third one. Allow me to change. Which one would you like to change into greater than? I don't want you to think that, because when we work on the second one, it's going to be the same. So which one would you like to change the inequality symbol to? It doesn't matter. First, top one? Very good. I'm going to change that one. So they're not the same, all of them. Good. So let's identify the first one. What type of inequality is it? Very good. Polynomial. Degree? Very good. Degree 3. The next one? Very good. Polynomial. Degree? Very good. And the last one? Of course. Very good. So let's start with the first one. In the first polynomial inequality, so all we are asked to do is find x values, such that this expression is greater than or equal to 0. So I'm going to copy it again. And we want to use a table. This is not the only method. This is the method I think it's fun and easy to understand. I completely agree. If you find a different method that works in all cases, I'll be more than happy to look at it. Feel free to do so. So this is x, negative x plus 2, x minus 3. So let's stop for a moment, because I'm sure you're asking yourselves, what is she doing? What is this? Right? So notice that the first row in the table consists of values of x, because the variable in the problem is x. That's the only reason. If I had y in the problem, I would have put y here. So this is the values of x, or the variable. This is the first factor. This is the second factor. And this is the third factor. Of course, this is what I'm interested in. I'm interested in this product. I'm not interested in each and every one of them by themselves. I'm interested in the whole thing, in the whole product. Second thing that I would like to mention is this table means nothing if I don't have a product or a ratio of factors and 0 on the other side.
I can't use this. So the left-hand side has to be fully factored, or the other, doesn't matter which side. One side has to be fully factored into factors, and the other side has to have 0. Otherwise, the table cannot be used. So now we're going to ask you, where is the first factor 0? For which value of x? When is this factor 0? For which value of x? Of course 0. Of course. Where is this value, or this expression 0? For which value of x? Of course. Where is this one? Excellent. Very good. So please give me those numbers in ascending order, because I have to put them in ascending order, and these are the only numbers I need. 0, 2, and 3. Good. So x, this row, has a 0. Under which number? Under? Of course. I'm just making sure that you follow. It's a silly question, right? So where does this have a 0? Under 2. And where does this one have a 0? Under 3. Now, what happens when any factor in a product is 0? What does the product equal to?
0.
Right. If any factor is 0, the product will be 0. No questions there. Now we're going to use what we learned in this chapter. What is x? What is negative x plus 2, and what is x minus 3? What are these functions? What type? Linear functions. The first one has a positive slope, which means it comes from, good. The second one has, right, it's coming from, good. And the last one? That's all I need. If we want to graph a linear function, we have two options. This is one option for the positive leading coefficient, or slope, and this is the other option for a negative slope.
Only because it's x. So we can say x.
Not x, the slope. Not x. X is not the slope. X is not the leading coefficient. The leading coefficient is 1, the leading coefficient is -1, the leading coefficient is 1.
But the degree.
It doesn't matter. This is degree 1. It's odd degree. It can only do this or this.
Wait, but if it was x squared.
They're all odd degree. They're all linear functions. That's why I asked first, what type of functions are they? That was my first question. Yes, if it's x squared, it's a different story. Yes, of course. Good. So on the first subinterval, I multiply two negatives. Sign of the outcome. Very good. In the middle, I have one negative. Sign of the outcome. In the next, I have two negatives. I multiply them. As you see, I don't even count the positives. Positive don't mean anything. In the last subinterval, I have one negative. Only now, I ask myself, which sign do I pick? Well, there is only one. There are two signs possible, but there is only one that is greater than or equal to 0. Which sign is greater than or equal to 0? Another silly question. Right. So then, is this product ever positive? Yes, of course. And that's the solution. For x between -infinity and 0, if I pick x between -infinity and 0 union, if I pick between 2 and 3, it's guaranteed that the product will be greater than or equal to 0. If I make the error of picking 1, or the error of picking 10, I would get a negative number. That's the result. And you can plug it in if you want to convince yourself of that. So then the final answer for this will be x in the interval -infinity 0 union 2, 3. That was the first example. Let's take a look at the second one. 4x minus x squared greater than or equal to 0. And what type of inequality is this? And you said polynomial. Specifically quadratic, right? Because the degree is 2.
what would you recommend? Say it again. Absolutely. Thank you. Negative x squared plus 4x is greater or equal to 0. Excellent. What would you recommend next? Yes, of course. I refuse to handle a negative leading coefficient. So I have x squared and minus 4x and 0. And then, of course, thank you very much. Good. So basically these two steps just cleaned it up. We didn't do much. So what is the next step now? Yes, of course. So the trick is I want to use the table. But I can't use the table unless I have a product or a ratio of factors and 0 on the other side. Good. Now I'm ready. X is the variable in the problem. X is the first factor. X minus 4 is the second factor. And what I'm really interested in is the whole thing, not just piece by piece. But I have to study those pieces to put them together. So I need a 0 for the x. I need a 0 for, or the x-intercept for x, and the x-intercept for x minus 4. Very good. And the other one is? 4. Excellent. In ascending order, 0 and 4. Of course, 0 and 4. Of course, 0 and 0. So now look at both functions, our linear functions, with what type of slope? Good. So the sequence of sign must be the first subinterval I multiply, because that's what I'm doing, multiply 2 negatives. And the next one I have a negative. And the last one no negatives. Now I ask myself, sorry. Now I ask myself, what do I want to pick? So which sign is less than or equal to 0? Good. Is this product ever negative? If you pick, that's it. As I said, it's like a puzzle. X in the interval 0 to 4. And there is just a minor difference with rational. And this is the end of chapter 3. I know. So I'm just copying what I came up with. I came up with x minus 1, x plus 1, x plus 2, negative x plus 3, and we said less than or equal to 0. Is it table or chart ready? Yeah, because we have a product and ratio and product of factors, and 0 on the other side. So this time I have x minus 1, I have x plus 1, I have x plus 2, I have negative x plus 3, and I have the whole thing, which is x minus 1, x plus 1, x plus 2, negative x plus 3. How many numbers will you put at the top? Oh, the answer is 1 for each factor. But they have to be in ascending order, so be careful. Tell me from left to right.
1.
Negative 1.
Negative 2.
Oh, shit.
Negative 1, 1, and 3.
Excellent. Negative 2, negative 1, 1, and 3. So where do I put the 0 for x minus 1? Under?
1.
Excellent. For x plus 1?
Negative 1.
Excellent. For x plus 2? Of course. And under 3. Now careful, careful, careful. When x is negative 2, this piece is 0. What happens under negative 2?
It's not fine.
Thank you. Negative 1. When x is negative 1, this piece is 0. What happens to the whole thing?
Product is 0.
Excellent. When the numerator is 0, the fraction is 0. Great job. For x equals 1, this piece is 0. What happens to the whole thing? Very good. Awesome. For x equals 3, this piece is 0. What happens to the whole thing? Excellent. The same pattern for all of them except which one?
Negative x.
Right. This should take 30 seconds. Not a problem for her to spend too much time on. Count the negatives and tell me the answer.
Not an answer. Bad. Negative.
I see. Count the negatives and give me the answer. Count the negatives and give me the answer.
Negative.
Count the negatives and give me the answer. And count the negatives and give me the answer. Which sign do I pick? There is only one sign less than or equal to 0. Good. Which means so the solution will be x in negative infinity, negative 2. What do I put at negative 2?
Bracket.
Can I put a bracket? Union. Yes. Union.
Not letting you say this. Bracket and 3. Sorry, no, never mind.
That is it. I hope you agree that this was the easiest we've done, I think. No? Okay.
These are what's-
Some of you agree, some of you disagree. Okay? Good. So do we all have this?
No, ma'am.
Yes? But you do have a pencil though, so that's good. Thank you. Good, so let's start. I don't have anything else to teach you from these chapters, 2 and 3. So please do not forget to add 2.5 here. 2.5 was not part of this test initially, but now it is because we did not get a chance to put it in test 1. Okay, so hopefully we have 45 minutes left, roughly, a little bit more than 45, so maybe we can finish everything. Now, if you worked on some, oh, I'm sorry, I have a question. What was that question, Chris?
It actually went up to relevant. Did we do 2.7?
Of course,
We did?
yes.
Okay, then good.
So here it is. I remember what the question was. X plus 1 over 2x minus 3 with x not equal 3/2. Find f inverse. We know how to graph this now because we studied 3.5, but we're not asked to graph it. We know that rational functions are one-to-one. Remember all the graphs that we looked at? We can go back. And why not, since I have it up here? Look at this function. Is it one-to-one? Of course. Look at this function. Is it one-to-one?
Yes.
Yes. By the horizontal line test. Look at this function. Is it one-to-one?
Yes.
Yes. That's it. I don't have anything else. So this is a rational function. And what type, please? 1. What is the horizontal asymptote of this function?
1.
Excellent. Leading coefficient over the leading coefficient. Great job. Good. So the range will be anything but 1/2. This is a horizontal asymptote. But we don't have to do that. So we're asked to find f inverse. So it is one-to-one. We know that. Linear functions. Linear functions and rational functions are one-to-one. So what is the first step? Right, so y equals x plus 1 divided by 2x minus 3 is the first step. The second step, interchange. So x equals y plus 1 divided by 2y minus 3. We solved these a month and a half ago. I can't even remember.
Multiply both sides by 2y.
Or cross multiply because this is a proportion. It's the same thing. You don't have to change anything. I'm just saying it's easier to think in terms of cross multiplying because it's a proportion.
Yeah.
But you can multiply both sides by 2y minus 3. That's fine too. So this is 2xy minus 3x equals y plus 1. We're solving for y. So 2xy minus y equals 3x plus 1. We have to separate the terms. We are separating the terms that have y from the terms that do not have y.
So you next step is take a y out of the left
Of
side.
course, I factor out y. This is the only way. So it's 2y minus 1. And finally, y equals. We solved these a long time ago. So my suggestion, I say this to all my classes. Moving forward for you, moving forward, every weekend, please take the time to redo all tests. So right now for this weekend, if you have time, maybe not because you're studying for test 2, but the following weekend after I return your test 2 and you have test 1, moving forward every weekend, set aside time to redo the tests. Because, don't forget what you want to say, because 2 or 3 days before the test, the final exam, you're going to say, I need to review. I've been reviewing for 10 weeks, every weekend. Sorry, forgive me.
Is it supposed to be y 2x minus 1?
Of course, yes. I rushed to say something with no excuse, and yes, of course. Thank you. Sorry about that.
We're recording.
Yes, it's recorded now. I can change it. Yep. Whatever I say is recorded. So 3x plus 1 over 2x minus 1. Of course, x is not 1/2. We knew that from the beginning because it's a horizontal asymptote. So then f inverse will be 3x plus 1 over 2x minus 1. Very good question, very good example. Topic. So it was good. Anything else? Is there anything else before we start this working on these problems that you may have? Is this okay, Krista?
Yeah.
Perfect.
Are we gonna have a question? I know when on my math lab, when you had those types of problems, the next step was to
Show that they are
verify,
inverses of each other.
is that gonna be?
It's a little bit of a torture of type of a problem. It's kind of long. So I would say most probably not, but let's do one. Let's do just this one. Why not? It's a good practice. So we have f of x, which was x plus 1 over 2x minus 3, and we have f inverse, which is 3x plus 1 over 2x minus 1. Okay, so we want to show that they are inverses of each other. What do we need to do? Yes. F comp f inverse, which is f of f inverse of x, which is f of 3x plus 1 over 2x minus 1. I haven't done much, and I had a lot to write, because I strongly recommend write the definition first, write what it equals to, and then replace f inverse. And now look at f. Remember, when we look at f, we see this. Blah plus 1 over 2 times blah minus 3, and this is blah. Blah plus 1 over 2 times blah minus 3, which is ugly, because it's a complex rational expression. So 3x plus 1 over 2x minus 1 plus 1, 2, 3x plus 1 over 2x minus 1, and minus 1.
This was the pain.
Right, it's not friendly. It's not friendly. I agree. Because we have fractions at the top and fractions in the denominator. We have to fully simplify the top, we have to fully simplify the denominator, get one fraction over one fraction, and then flip the bottom one. And what should the answer be? If we did not have an error, and if this is correct,
Should be x.
Right, no.
say it again.
Should be x.
Exactly. Like, remember the inverse functions. I'm giving you $3, but 2 minutes later, I take it back. No deal. That's the idea. No deal. That's the meaning of inverse functions. If I apply them to x in any order, nothing happens. I multiply by 3, but immediately divide by 3, nothing happens to x. Why? Multiplication by 3 and division by 3 are inverses of each other. So if this answer is not plain x, this is wrong. Or maybe I made an error somewhere on the road. Any questions before we continue this? Okay, perfect. So the top, I have to find the LCD. Here I will distribute. First, 6x plus 2 over 2x minus 1 minus 1, and later on I find the least common denominator. What is the least common denominator in the numerator? Right, 2x minus 1. Remember, this one needs an adjustment. We need to multiply the top of that fraction by 2x minus 1. Can anyone dictate the top here? Very good. 3x plus 1 plus 2x minus 1. Awesome. Thank you. Obviously, these two will go away. So for now, I have 5x over 2x minus 1. And now I'm able to continue with the denominator. What is the least common denominator in the denominator? Okay, very good. 2x minus 1. Remember the same thing. This needs a 2x minus 1. What do I write?
6x plus 2.
6x plus 2.
Plus 2x.
Careful. Minus 1 times 2x. And minus 1 times negative 1.
Positive.
Very good. Awesome. Very good. So the numerator now is 5x over 2x minus 1. I flip the denominator 2x minus 1 over. This is 4x plus 3. And this is awful. I have to go back and look at and see what I did. Okay. So x, y, y, correct. 2xy minus 3x, that's correct. Y plus 1. 2xy minus y, correct. 3x plus 1, correct. 2x minus 1, correct. 3x plus 1, yes, that's correct. Yes, that's correct. Did I copy it correctly? I did. I copied this. I copied correctly. This I copied correctly. Okay, let's see now. So I copied 3x plus 1 correctly, yes. And then 3x plus 1 over 2x minus 1. Ah! My apologies. I copied negative 1 instead of negative 3. Sorry about that. Sorry about that. I don't know why. This was negative 3, but I copied negative 1. Okay, so far I'm okay with the numerator. I'm not okay with the denominator, so this is negative 6. Negative 6x plus 3. Okay. So far, so good. I copy 5x over 2x minus 1. That's okay. I copied this. That's okay. These two go away, and the denominator is only 5. I knew something was fishy because I didn't think we had an error in calculating. Excellent. So these two go away. These two go away, and the answer is indeed x, as expected. Yep. So, any questions on this? Thank you for bringing that up.
I just know I kept getting it wrong in my math class.
No. So, is that clear now?
Yeah.
So, as long as you don't copy like I did something else, you should be
I
fine.
think I did that a couple times, so yeah.
Good. So, let's go back to this. And please choose. I'm hoping that you covered most of it. So, or whatever you need, I'll do whatever you need. 11. Let's start with 11. 7, 8, 9, 10, 11. Divide using synthetic division. I did not show that in class for the same reason. They removed synthetic division, and my colleagues decided they removed synthetic division and removed type 3 of rational functions. So I didn't show the synthetic division, and I did not show the type 3. So We can, yes, you will be asked to use the long division though. So we can do log division, but not synthetic. Ready? I'm sorry? Yeah, with this one, yes, of course. Yes. So we have x to the fifth, power 4 is missing, 10x to the third, power 2, power 1, I should say degree 2, degree 1, and negative 11. And then we are dividing by x minus 1.
Is it okay if we put zeros in place?
You can if you want. Oh, yeah. Whatever works. I agree with it. Any variation from this, I completely agree. Please use it. Anything that helps you, please use it. Okay, so x times what is x to the fifth? Very good. Remember at the top, I like to refresh my your memory. At the top, sort of, we don't lie. But when we rewrite, we lie, meaning the opposite. So x to the fourth times x is x to the fifth, but we have to subtract. X to the fourth times negative 1 is negative x to the fourth, but I have to subtract. I get x to the fourth plus 10x to the third. Next question. X times what is x to the fourth? Sign, please. Always give me the sign and the term. Very good. Yes. Plus x to the third. Perfect. Plus x to the third. So notice that x to the fourth, x to the third, you cannot go back, right? You have the degrees will decrease, of course. X to the third times x is x to the fourth, but now we have to subtract. X to the third times negative 1 is negative x cubed, but I have to subtract. I can't bring this down just yet. X times what is 11x cubed? Sign, please. Perfect. 11x squared times x is 11x cubed, subtract. 11x squared times negative 1, negative 11x squared, we subtract. X times what is 11x squared? Positive 11x. Perfect. 11x times x is 11x squared, subtract. 11x times negative 1, negative 11x, but I have to subtract. Finally, 11x, and I bring down the lasting line. X times what is 11x? That's it. Positive 11x, subtract. Negative 11, subtract. So the final answer,
You got lucky with that one. So
yeah,
remain.
no remainder, yes, no remainder. It happened. So the final answer would be, of the division, x to the fifth plus 10x cubed minus 11 divided by x minus 1 equals x to the fourth plus x cubed plus 11x squared plus 11x and plus 11. No remainder. Which means that x minus 1 represents what for the numerator? If there is no remainder. X minus 1 represents what for this quantity? Is a, I'm looking for a word, is a factor. Yes, correct. You're correct. There is no mistake. Everything you said is perfect. Indeed, x minus 1 is a factor of x to the fifth plus 10x cubed minus 11, or x to the fifth plus 10x cubed minus 11 is a multiple of x minus 1. Perfect. Good pick. Anything else? Next question. Choose anything you want.
Can you do number 6?
Yes,
Remember what I had your
yes, number
table?
6. Where is number 6? Yes, yes, very good. Good pick. In number 6, the function f and g are defined by the following tables. Here's f and here's g. Okay, so here we're asked to find f inverse of g of 8. Forget about that, just please give me g of 8. Do we agree that g of 8 is negative 6?
Yes.
So therefore, we are asked to find f inverse of negative 6. So careful. F goes from this to this. F inverse goes from this to this. You already gave me the answer. I just wanted to explain for everyone. So then f inverse of negative 6 must be 7. Is this clear, everyone? Yes? Any questions? Perfect. Please choose the next. Number 10. Very good. So we are given f of x equals negative 0.1 x squared plus 0.6 x plus 5. We are told that a ball is thrown upward and outward. We've had something like this with a height of 5. From the height of 5, the height of the ball f of x in feet. So I'll take notes. This is in feet and x in feet as well. Horizontal distance can be modeled by this equation or function. X is the ball's horizontal distance in feet from where it was thrown. Use the model to solve whatever. So part A, what is the maximum height of the ball and how far from where it was thrown does this occur? Exactly. It's a quadratic function. I have to find the vertex. Very good. So then the vertex, how do I find the x coordinate? Because I can't find the y coordinate before I find the x coordinate. Excellent. Negative b over 2a, negative. Make sure that this is arranged in descending order. Otherwise, you may incorrectly identify a, b, and c, and that will be wrong. Okay, so what is b? B is 0.6, and 2 times a is negative 0.2. Multiply top and bottom by 10. 6 divided by 2 is 3.
And you just plug in.
Excellent. Yes. So this value right here is f of 3. So f of 3 is negative 0.1 times 9 plus 1.8 and plus 5. So negative 0.9 plus, what is this, 6.8. So this will be 5.9? So this is 5.9 feet and feet. So I can already graph that. What is the y-intercept of this function? Right, because I plug in 0 and I get 5. Very good. So 1, 2, 3, 4, 5. It starts here. And this is 5.9, so that's 6. So 5.9, 3 units away. 1, 2, 3, and 5.9. So I already know this. I don't know where it's going to land, but I already know this piece. Perfect. Part B. How far does the ball travel horizontally before hitting the ground?
That's when you use the quadratic formula.
Right, because I'm asked to find what? The
distance.
Oh,
the x-intercept.
Very good. The x-intercept indeed. So x-intercepts when f of x is 0 or negative 0.1 x squared plus 0.6 x plus 5 equals 0. And now you know what I am going to do first. Even if you don't say it, I will do it.
You're going to divide that negative out.
Or multiply both sides by negative 10. Multiply both sides by negative 10. Do you have to? No. But I refuse to work with those numbers. That's me. You don't have to. So with the graphing calculator, let's punch in. Oh, let me write it first so you can see it, and then. So x equals negative b plus or minus b squared minus 4ac over 2a. I hope you agree that this is more decent than having decimal numbers in there, but it's up to you. There is no requirement here. So the left parenthesis, 6 plus the square root. You know I love parentheses. So 236. Outside, left parenthesis, and divide by 2. And I will repeat, changing plus into minus. Of course, this makes no sense, but it's there. So 10.68 feet, and the other one is a negative number, negative 4.68. So now we know how far. So that's 10.68, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10.68, the vertex 3, 5.9, and this is 5. And if you want 1, 2, 3, 4, this will be this one, but we don't care for it.
So is the,
Yes?
I don't, so like when we do this, when we do the